Okay, so 1 second. Do you see presentation?
Sorry, yes, we see. One more thing, if you have any questions, just let us know on chat or wait until the end of the presentation. There will be Q&A session and we'll unmute you and you can ask directly the Maxime about the ClickHouse. So let's start.
Okay, hello everyone. My name is Maxim. I'm developer of ClickHouse, and today I will try to make some introduction to ClickHouse. We will discuss some details, and I also will show some demos why you should use ClickHouse. So what is ClickHouse? Probably most of you already hear something about ClickHouse, but actually not everyone. So ClickHouse is column-oriented database management system. It uses shared nothing architecture. It also supports SQL, but with some additions. For example, there are non-standard additions for arrays processing or some custom functions for aggregation. It's also open source, Apache 2 license, very permissive, so you can fork it, make some changes to it, and it's also easy to contribute to our project because we accept mostly all pull requests with some features. Okay, also ClickHouse can run everywhere, so you can use it on bare metal, you can run it in cloud on some instances, and so on. Why do we need ClickHouse? Basically, the most valuable task for ClickHouse is real-time data insertion and analytical queries. It's the most important part of ClickHouse is data aggregation. It's the task that it do the best. And actually, it also do it very fast. And the most valuable feature of ClickHouse is its speed. So you can see some, for example, Twitter comments about ClickHouse. Okay, so I will try to introduce you to some history, how we came up to ClickHouse, why we did some architecture decisions that way. So let's start. The first thing that I need to say is that ClickHouse initially was developed in Yandex as part of Yandex Mexico project. What is Yandex Mexico? It's like a Google Analytics, but in Russia. It's first in Russia, and it's second in the world by traffic and market share. And the first commits in some projects that later was transformed into ClickHouse were in 2008. Basically, what was the problem? The problem was that there was a lot of data, and clients, users wanted to generate a report. A report can be, for example, how much people visited site with some categories and so on. And the problem is that there are a lot of data, and this data need to be aggregated. And not just aggregated, but aggregated by different dimensions. For example, some client wanted to slice his data very granularly and find a lot of interesting cases in his data. So we cannot just generate a lot of predefined reports and store them. For example, in some classical database. Okay, so it was a side project during that days. And there was a hypothesis that if we have good enough column-oriented database management system, we can we could store all data in non-aggregated form and aggregate it on the fly. So basically, it will be infinite customization for the client. It could generate any report, and it will work fast. Okay, so let's start with some architecture overview and some architecture problems that was during that days. So basically, the main concerns of query speed is data locality. For example, for HDD data drive, the most performance issue is speed of seek. Basically, one seek on HDD data drive is like 20 nanoseconds. And your query, most of the time, will wait input output. Here is on the slide, there is a picture about data locality on disk. It's artistic view, but it can show some ideas. So from left side, we can see how, for example, some classical database can store data. It's not stored locally on disk. It's some part stored there, some part stored in other place. And basically, when we need to read this data, we need to make a lot of disk seeks to read, for example, some data for some table attribute. But if we have column-oriented style of storage, we can store it on disk like I show on right picture. So it gives better locality and less disk seeks because we can sequentially read data from HDD. Let's talk about other property of column-oriented systems. In column-oriented system, for example, we have a table with a lot of columns, or for example, some fields. And when we need to read data from classical oriented, so for example, from Postgres or MySQL, we will read all data, but for example, we need only 2 or 3 fields. And but we will be required to read all data from disk. It can be very slow because first we read additional data, and as I said, we will need to make a lot of disk seeks. And there is a picture how this can be done. For example, we read some rows, we read all data, but there are only 3 rows required. If we compare that to how column-oriented databases read data for some reports, it's much faster. So we basically read only data that is required to generate a report from disk. It's also very interesting that this way of data storage provides better data distribution because all data related to column is distributed normally, and it can be compressed much better. So there was developed some system, and we start use that system in 2012 for some production tasks for data processing. After that, in 2 years of development, there was information that this system resolves all tasks related to generating reports, and mostly all Yandex Mexico moved to ClickHouse. So this system was used in production as core service technology internally. So I'll show you some interface, how this was from client perspective. So basically, there was client has some properties related to sites, and it can combine them in any way how client needs and generate some reports. And the most valuable thing is that these reports generated on the fly. There are no any pre-aggregated reports, and any report is generated in real time. What about our cluster size? It's huge. So basically, we insert 120 billion of records daily. We have around 70 petabytes of data if it will be in uncompressed size. But as I said before, we compress columns in ClickHouse. So it's around 6 petabytes of data. And it's around 2,000 servers in our department. But I will show you today that if you need to try to ClickHouse and check how fast it is, the one server is enough. Also, I wanted to say that our cluster is not largest. The largest cluster size, for example, there is in ByteDance. It has more data, and Cloudflare also has more higher insert rate. Cloudflare uses ClickHouse for DNS traffic analyzing. So they have also very huge cluster, and they contribute some features to our master branch. So how we developed ClickHouse? After it was main core technology of Yandex Mexico, it was distributed widespread inside Yandex. So other departments started to use it. There was feedback that this technology is interesting and it can be open sourced. And in 2016, this technology was open sourced and released by Apache 2 license. All development after that was on GitHub. Currently, more than 1,000 companies are using ClickHouse. Why open source? There are a lot of concerns about open source and should some internal technology be open sourced, but related to ClickHouse, technology is too good to be used just inside Yandex. Currently, a lot of great features, some of them we will discuss today, come from our external contributors. For example, ClickHouse is very popular in China, and a lot of cool features were contributed to ClickHouse by China developers, for example, from ByteDance developers. Also, to have more fun. When, for example, some feature is implemented in open source, you will get feedback very soon. And also, your technology will be used by a lot of people, and most of the bugs, they will be cached early because there is a lot of customers and there is a lot of needs. For example, some features that we develop, we couldn't predict that they will be used the way they did. For example, we added some feature for database connections, and some customer reported that it probably used by not so many customers, but they reported that we have some issues that we can later fix. Okay, so let's talk about some goals as ClickHouse developers. First, we satisfy our needs inside our company. So basically, we get some feedback that some feature is required. For example, materialized views that are supported in ClickHouse were required by Yandex Mexico. There is also some additional features that come from our company internally. And we also need maximum widespread of ClickHouse as open source product. There are some rules of successful open source product. Basically, we must solve actual problem and do it better than others. For example, currently our goal is to be default choice of open source analytical database management system. Okay, so I'll talk about some other our notable users. For example, we used, for example, Uber use our technology, VKontakte is a Russian social network, uses our technology. As I said, Cloudflare uses our technology. And we basically from a lot of domains, customers are using our technology, and we get a lot of feedback from them. So let's talk more about technical stuff. Why they are using ClickHouse? So ClickHouse, as I said, is column oriented. It's also distributed, so you can shard your table by a lot of servers. It's also linearly scalable. So basically, ClickHouse will work as fast as your hardware. Theoretically can. It's also fault tolerant. We support different types of replication. We can replicate your data, so it will be safe. Why we fast? We support vectorized query execution. So basically, we can use most performance synced instruction during data processing. And we also support runtime code generation. Both this vectorized query execution and runtime code generation allows us to get maximum speed for your queries. Also, we support data ingestion in real time, so you can basically insert a lot of data and ClickHouse will eat it. Also, we support a lot of integrations. We basically support integration with most popular database management systems. Also, we support a lot of integrations with some key value storage like Redis. We support integration with Kafka and so on. We also support integration with some JDBC and ODBC drivers, so probably any system is supported and can be integrated into ClickHouse. Why ClickHouse is fast? First of all, we need to talk about high-level architecture. There is shared nothing architecture, and we also use massive parallel processing. If we talk about data storage optimizations, the most important part of data storage optimization is our column-oriented storage. So we store all data in columns. And also we sort all stored data by primary key. It's done by merge tree table engine. We also support data compression, and all your data will be compressed. For example, as I showed before, the uncompressed data size of Yandex Mexico cluster is around 60 petabytes. But if it was compressed and it is compressed, its size around 6 petabytes. It's also important because data compressions sometimes can increase your query speed because there will be less disk read and more processing data in L2, L1, and L3 caches in processor. Okay, what about other sides of our optimizations? We use the best algorithms that possibly can be found, that we can possibly find on the internet. All good algorithms will end up in ClickHouse. We use a lot of optimizations, for example, for substring search. We use Volnitsky algorithm, but there is a lot of algorithms in ClickHouse related to substring search that we use. We choose them on runtime. So the best possible variant will be chosen by ClickHouse on runtime. Also, we use most popular, most fastest open source libraries that we can find, for example, related to regex processing. We use Hyperscan and Ray2 regex engines. Also, for some JSON, for work with JSON, we use SimJSON and so on. So basically, any good new algorithm will end up in ClickHouse. We also have a lot of our interesting cases. For example, for LZ4 compression, we added some additional features, and we choose best block size on runtime. Now let's talk about some low-level optimizations. So as I said before, we have vectorized query execution engine, and each column that we read from disk can be processed later as array. So it allows us to use newest SIMD instructions just for your CPU. For example, SIM decompression, SIM string operations, SIM text passing, and so on. Let's talk about additional things that is in ClickHouse. So basically, we use a lot of specializations for each algorithm. For example, we have function unique combined, and this function has 3 different specializations for your data: for small, for average, and for big sizes of data. Also, the most important part, as I said before, in ClickHouse is group by and aggregation. We have more than 60 specializations for group by, for nullable columns, for low cardinality columns, for integers, for strings. For any type, we have specialization in ClickHouse. And algorithms optimize itself for data distributions. For example, LZ4 decompression is optimized with Bayesian bandits algorithm. So we choose the best algorithm in runtime. How client can interact with ClickHouse? We have basic HTTP interface. We have a client, ClickHouse client, that I'll show you. We have JDBC and ODBC drivers, and we also support MySQL and PostgreSQL protocols. So you can connect to ClickHouse using your tools. We also have a bindings for.
We have questions. Sorry for interrupting.
Okay.
Like to answer right now or do it later?
I can answer them right now, so we can have some sort of dialogue.
Okay. So, a question from Raf. How would you convert a traditional database system into ClickHouse? So you have any scripts or example? I imagine the situation that someone is using the Postgres or MySQL or any other database. So is there any way to migrate it to ClickHouse?
Okay, so there is a lot of, you can do it with a lot of ways. So for example, let's take that you have some MySQL database and you want to integrate it into ClickHouse. First, ClickHouse support queries. For example, you can use MySQL table in ClickHouse. ClickHouse will connect to your MySQL instance and read data from that instance. That's called MySQL storage. There is also another type of table. We have MySQL, materialized MySQL. It works a little bit different. You provide necessary connection settings for your MySQL server, and ClickHouse will download all data from MySQL, and it will also download changes that were in MySQL later. So basically, you have your MySQL instance. It's under production load, right? And you have ClickHouse instance. You create materialized MySQL table, and it will be like a replica, read replica for that table. So basically, we have the 2 ways, and we also have additional type of storage in ClickHouse. It's called dictionary. I will talk about dictionaries a little bit later.
Okay. Ralph, are you happy? I mean, are you satisfied of the answer? Okay, let's move forward.
I mean,
Oh.
all good. Obviously, I learned by doing things, so I probably will have to deploy VM and play with it.
Okay.
Okay, so stay with us because Maxim prepared a live demo, right?
Yes. Yes.
Yeah.
Okay.
That's a good one. Yeah. Okay. Thanks.
Okay, so let's move forward.
Okay. So let's move forward. There are bindings for most popular languages and analytical tools for ClickHouse that are on screen. Now related to integrations. So there are two ways of integrating external storages into ClickHouse. First, there is a dictionaries, and what the dictionary is. The dictionary is some sort of data structure that will download your data from some external source. It's not only MySQL, Postgres, it can be anything. For example, some HTTP handler, some file, some executable script, whatever. It will download this data into ClickHouse, and it can be later queried with dictionary queries. I'll try to show that in my examples. And there is also a storage. Storage is a table in ClickHouse. So there can be storages for most popular database management system, like we have MySQL storage, PostgreSQL storage, we have also Kafka storage, RabbitMQ storage, and they work in similar ways. So we have integration with most popular systems. Also, let's talk about some advantages of open source. So it's better product quality because we get a lot of issues from our customers if they find any bug. Also, a lot of people look into our code and they can improve it with some features. Better Yandex representation as the company. There is also additional benefits for hiring developers more easily because most of the developers wanted to work in open source because that will be like additional motivation for them. And drawbacks is hard work. And we in team working really a lot. So also a few words about our community. We have a website that I'll show you a bit later. We have a mailing list. So if you have some private question, you can ask this question in our mailing list. We have a YouTube channel. I'll show you 1 second. With a lot of presentations and information about ClickHouse from our meetups. We also have 2 Telegram chats for English and Russian clients. We have our GitHub. I'll show you. Right now we have around 90,000 stars, and there is also around 4,000 of forks. It's also important that currently we grow exponentially, so we run very fast. There are a lot of new features, and there are a lot of pull requests. Okay, so we also have a Twitter and Google Groups. Okay, now I can answer some questions before I'll try to show you the demo. And I also wanted to show some additional things from our side. So first, let's answer some questions. If someone have questions.
I wonder if you have somewhere on your documentation algorithms and optimizations described, maybe? Because you told that there is a lot of it, right?
Yes, basically we use a lot of algorithms, and it's very important that there is no compromises in ClickHouse. So basically we use the best possible algorithm, no matter how hard it to implement it. So for example, in our documentation, I'll show you. There is descriptions about our merge tree engine. Merge tree is our column-oriented engine that stores data in columns, compress them, and they are sorted. There are a lot of additional details, but mostly that's it. And all algorithm is described in our documentation, and it's also very important that our project is open source. So basically you can find this code in our code base, look into it. We have a lot of documentation in code, a lot of comments. So basically, if you have any questions, you can also ask them in on GitHub. If you have question related to some algorithm, and we can comment this code with comments if there are something, if there are some questions related to code, because we have a culture that code should be documented and is easily readable by everyone.
Okay, thank you.
Do you need to do any performance tuning for a ClickHouse?
Could you please repeat?
Performance tuning, like do you need to verify indexes, make sure that the latest data is on a fast storage, do a database fragmentation, like move the old records that are not really frequently accessed onto a slow storage?
Actually, ClickHouse works good out of the box. So if you need to tune some settings, it should be done very carefully, because mostly our settings by default are fine. There are a lot of settings in ClickHouse that you can tune. And for example, there is a lot of settings related to caches, but and there is a lot of settings related to compressions. I can show, I can talk about some stuff that, for example, there were a client that asks us, could we implement a feature to disable compression? And we asked that client, why do you need that feature? Because compression is in ClickHouse works out of the box very well. But client was for clients that was important, we implemented that feature, and later it turned out that his data no more fits his disk size. So when you tune some settings, it's very important to understand what you actually do. In ClickHouse, you can tune a lot of settings, and for example, for your specific case, you can improve performance a lot. But mostly, ClickHouse is fast out of the box, and I will show you how fast it is today. Sorry, I probably didn't hear you. If you...
Sorry, Maxim, I got an unstable internet connection, just dropped. But that's fine. I will watch the recording.
Okay. Do you have any other questions?
No, let's see the demo.
Okay. Maybe there are some other questions in chat, for example. Circle chat. I'll check.
No, I don't see any questions on the chat, so let's move forward and then organize the discussion. Okay, open. I mean,
Okay, fine.
When you show the live demo, we can mute everyone and talk like in pub. Okay.
Okay, so I also wanted to show you benchmarks. These benchmarks are open, so anyone can reproduce them. I'll show you. So we have data sets that are open. It's part of data from Yandex Mexico. It is obfuscated and it can be downloaded from our website. And you can run our performance testing scripts on our data and send results to us. Basically, one sec. There is a comparing ClickHouse on different hardware, also with some against some other database management systems. Actually, I couldn't find it here, but it can be found on our website. Okay, so let's go to some demo. I'll stop side screen sharing and we'll share a console.
Yeah, I can confirm about the comparisons because before the presentation, I also saw it and also comparing to Vertica because it's our current solution. I mean, the Vertica. So yeah, let me find a link and I will share on the chat. Okay. So
1 sec. Yeah. Okay. I actually find it. I'll show it. 1 sec. Do you see screen?
Yeah.
Yes, we do.
Okay, so we have performance comparison of analytical database management systems on our website, and there are a lot of queries. All these benchmarks are reproducible. So we actually almost always a lot faster than Vertica or Greenplum. We also can add checks with some other systems. 1 sec. It's 1 billion of data. So it's a lot of data, and you can see that ClickHouse processes queries much faster. Okay, so now let's go to some demos. So what I actually wanted to show you, okay, so I have this single machine. It has 640,000 megabytes of RAM. It's 80 cores, and it also uses HDD drive underneath it. What I wanted to show that we have a data from GitHub Events. 1 sec. Find the link. it's so basically we have a data from GitHub Events, and we can query some of that data. So basically it's 65 gigabytes of data. It contains 3 billion of records. And for example, we can start querying that data. First, I'll show you how introspection works. For example, we can check all tables in ClickHouse that are not system tables. System tables are tables for introspection. So let's find out. Let's find this table. It's called GitHub Events. This table. It has a lot of columns. It uses match tree engine. It's ordered by event type, repository name, and created date. Other settings are by default. So it's 65 gigabytes of data in this data set. So first, let's start with some basic queries, like let's find out how many stars were given on GitHub. So when star is given, it type is watch event. So this query worked very fast. It processed around 270 million of rows and throughput was around 8 gigabytes per second. Okay, so it's important to understand that these data were read from disk, but some of this data were in page cache, so it fits in RAM. Okay, let's go and check some other queries. For example, we can check not only how much stars were given, but for my most interesting repository. So basically, currently there are around 20,000 stars given to ClickHouse. It's also interesting that in this dataset there are no event type when star was ungiven. So on GitHub side, currently there are around 19,000. Okay, so let's find out top repositories by stars. For example, such query processed a lot of records with a bit less throughput, and it took around 1 second for it. And we can see that the free code camp is the most popular repository on GitHub, because this 996 issue is some repository related to Chinese work hours analyzing or something like that. So do you have any questions related to? I see there is a question in chat, so I can ask, I can answer this question. Okay. So question is, how good is ClickHouse in a join between large fact tables or in joins of many dimension tables with fact tables? ClickHouse is much better when you have less tables and less joins. Currently, we support joins, but from our internal architecture, it's better to have less joins and less data join. It's much better to have a huge fact tables. Did I answer question? One second. I'm not sure if. Okay, so let's move on. We can also check the repositories, for example, with the maximum amount of pull requests. Let's lower some limits. Okay, so some Nix OS is this repository. Okay, what other things I can show? One second. Do you see my screen?
Yeah,
We see console right now.
Okay,
Yeah.
one second. I'll need to share browser for a second. So also a bit about our site. So we have a huge reference for most of our, a lot of internals are described here. You can check, for example, how about our functions, aggregate functions, how some of them work internally. So basically, this documentation is up to date. We update it with, we try to update it with our code base. And if there is some issues in documentation, you can easily fix them. Documentation is also stored on our GitHub. Okay, I can answer some additional questions, or maybe I can try to show some example if some functionality is interesting specifically to.
Okay, if you need to show break, let me know, because we have a book to win, or we can move with the example. So up to you.
We can probably start with some questions if
You
the
open question, right?
Okay.
Okay, so who's next? Open questions. Before we start, I have questions. So as a organizer, so I will be the first one. So you can prepare your question. Just let me know when you'll be ready. So my question is, if you're building the cluster, I mean, it's the fault tolerant. I mean, so you replicated the data between the clusters, and how it's the organized. I mean, is there any coordinator, or each node is the master and coordinator at the data node, or how it works?
Very interesting questions. Very interesting question. I'll answer it. So currently, each node is master. Before, we use Zookeeper for as our coordination service, but right now we have a ClickHouse keeper. So basically we try to move on without the keeper like Kafka did. Also, so currently we have our own coordination system. It's implemented using new Raft. So basically it's a Raft underneath this coordination system. So currently each node is master. Okay, each node is master in logic of our replication, but in logic of our message passing, we use Raft algorithm.
Okay, and then a backup system or some, let's say, like cron, so running the schedule job or something like that.
We have, one sec, I'll show you. It doesn't have any official ClickHouse backup system, but there are some open source projects that did this already. Basically, currently there is no official backup system for ClickHouse. But for example, if you use some cloud provider, backup will be done by default, right?
Okay, and a built-in monitoring system or an exporter like Prometheus or something like that?
Yes, we have integrations with Grafana, with Prometheus. We also have a lot of introspection in ClickHouse. For example, we introspect our cache usages, we introspect CPU events. For example, we can check how much there were cache misses for some query. Also, we can check stack traces. That it's really important in some cases. For example, we can check if there are some deadlocks on instance. We can just connect to them, get stack traces, and check if it's deadlock and so on. So we have we have great introspection, and probably we can we can analyze any problem in ClickHouse and check only using our internal introspection.
Okay, next question from Roman. Are you planning to release some operation configurations management tooling for ClickHouse clusters?
Yes, actually, there is already cloud in Yandex. So basically, there is a Yandex cloud. You can create ClickHouse management system, add instances, add Zookeeper instances for coordination, and it will work out of the box. It's also, you will also get support for some issues if there will be some issues. Or if you ask about some tools like, for example, if you ask about some tools like for example, binary tool to perform some cluster operations, probably not, but a lot of queries can be run on cluster. So you can, for example, create table on cluster and so on. So basically, probably we will not need this.
Okay. Is there any option to use example like in Elasticsearch, cold, warm, hot nose, when the hot is your fastest machine that you have, and with the data that is using heavily, and the cold one when is the slowest, in the same way is cheapest, and also you don't use it too often, or maybe there is an option to store some parts on S3 or something like that, like external.
Yes, we support S3. So basically you can, for example, store your data on your servers and move some data to S3. So it will work, but we didn't have very good support for that cases. You can create such configuration, but it's not recommended probably. So it will work, but it can be not very fast. We work on better, currently we work on better integration with S3.
Okay, and another question related to what I mean, the question from Roman: is there any UI to manage it, or general to use like pgadmin for PySQL or something like that?
It's interesting question. Actually, you can connect this, for example, pgadmin to ClickHouse, or with some MySQL bench probably. You can connect to ClickHouse with these UI tools, because we support MySQL and PostgreSQL protocols, so it will work. But there is also additional tools called Tabix. 1 second, I'll check which browser I'm using. Okay, 1 sec. Show it. 1 sec. It's open source tool for ClickHouse. It supports running queries, visualizations, and so on. So basically, you can use this tool if you need some UI.
Nice, cool, thank you. So any other question? Don't be so shy. Last questions, and the book is waiting for new owner, so let me know who is interested. It's Site Reliability Engineering from O'Reilly, and it's Polish edition, to be honest.
Okay, Max, is the database a trigger based, or how would I configure database to respond to events?
Okay, so currently triggers are not supported in ClickHouse, but we support views, materialized views. So basically, for example, if you need to create to update some aggregations, you can use materialized views. But you probably ask if you can create some hooks, external hooks. For example, if some data is inserted. So basically, we do not support triggers right now.
Fair enough. Thanks.
It sounds like ClickHouse, it's really, I would say, it's not the startup. I see a lot of, I mean, documentation is pretty nice. To be honest, I never saw it before, so it's my very first time. And I see that there is a lot of features and options. So it could be really a nice choice. And comparing to the HDFS, I saw that the benchmarks, so it's much more faster than HDFS. So it seems like the technology itself, it's pretty complex. No, complex is the wrong word. Pretty adults, I would say. I mean, it's not going up, but still, it's not in the development mode and startup mode, but it's the good technology. It's already solid. Yep.
Sorry, if I'd like to play with this ClickHouse, where would I start?
You can just download release from our, for example, site or from our GitHub. You can also download it from DBMS package. You can just download Docker image and you can download some dataset. So basically, I'll show you that we have a lot of datasets. For today's few examples, I choose GitHub dataset, but we have a lot of them to play and make some queries and try to understand better how ClickHouse work.
Yeah, and I shared the link to the Docker. So I think it's also a good way to start with the small server, just to learn how it works. And yeah, I see that all the commands are there, so it also could be really easy to start from the scratch.